Back at you. How do you do, Michael? Michael Fremer.
Hello, Michael. Nice to meet you all.
Nice to meet you.
Wow. This is where he.
Yeah, I visited here when he was still alive. Yeah.
Absolutely.
Now, how long has this Model 10 been? Have you seen this?
Well, we saw a Model 10, but didn't look.
No, this is something new.
You haven't seen that.
No.
So these are all the gauges that we use on manufacturing for checking the work, and obviously they've got to be held at an ambient 20 degrees, which is what you feel in here.
Oh wow!
So this is 365 days a year.
Wow! Why do they have to be?
They don't. So the metal doesn't expand.
So the metal doesn't change its shape or size.
Contract.
Yeah.
Or that would contract or expand by quite a sizable amount.
Whoa.
If you look at this part of the building, this wall was actually the end of the building, and that wall up there was the end of the building, and that and there. So it was quite small relative to what we've got now. And then it's expanded that way, it's gone that way, it's gone over the end.
Where did this? I mean, maybe this one.
5960.
Oh, okay.
And then in the 70s, the very early 70s, the upstairs and the offices were added, the curtain shop was added.
Now, what percentage of what we're seeing here is work on turntables, and what percentage is precision machining for other products that you involve?
I'd say it's about 40-60 at the moment in favour of SME products, and 60% will be other pieces, and then down the other what will be 100% other pieces.
So 40% of what we're seeing here is working on SME products, but turntables and
pick up.
Yeah, that's pretty impressive actually.
Yeah. That come out of there. The hexagon head goes in there, and you could do all of our little screws that fit in the head shells, any hexagon screw. We'll make it on the machine out there, and this here, which is a little gasket, you see, that sits in this weight housing here. See, that sits in there, and then the tone arm sits on top of that, and they're held together. And that gasket allows the housing to move on the pickup.
Slide easily.
Slide easily. You see, when we rumble these, which gets rid of all the sharp edges, we string them all up with a spacer in between, so they don't damage each other when they go around in a circle. If you were to allow them to free fall, they will bang into each other all of the time. In a rumbling machine,
it looks like a spine.
Before it goes into the plating shop, we have to rumble it through here, just to take all the sharp edges off, which I showed you down in the other department.
What is this made out of?
That's only a man-made bonded.
Is it ceramic or something?
Yeah, ceramic.
Some aggregate.
That's a ceramic, which is a hard needle. Used for polishing. We polish our turntable springs with ceramics.
How long is it there?
That is actually the circular piston inside it. So when that's up there like that, that just looks like it's part of the suspension. But inside there you can see there's a circular piston. You see it? And then the cylinder sits underneath like that, and in the cylinder there's fluid, and there's also another spigot inside there. So it sits inside, and then that part of it engages in the silicone fluid, which gives you the lateral damping on the four corners, whereas the suspension bands then give you the vertical.
And that keeps the whole thing from moving.
So that's it's fabricated, you see. We make two pieces. We make the outer cover, which is this piece here, and then that inner piece, which has the O-ring groove in here. So obviously when you ship it, you have to lock it down, and it locks down on an O-ring on the cylinder underneath. Okay, and that's what we were talking about, releasing. It releases it then to engage in the fluid. So we make that inner piece, and we put the two together, and you can see where they're soldered. It's an arm socket for a Series 2 and an M2 arm and so on. But years ago we would have 2 or 3 people actually manufacturing this, because somebody would have to turn the blank and split it and so on, and it's drilled here and it's tapped. And the whole lot, it comes off there complete. And there isn't, you see, it's working, all the heads are working from different ends. It's a 13-axis machine. It's claim to fame is that within the capacity of the machine, there isn't anything that's been designed that it can't finish.
Wow.
Because it covers every aspect over the 13 axes on the machine.
Amazing. And what year is a machine like this manufactured?
We've had that for about 7 years now. We've had this one for about 10 years.
And they make watches too.
They were, well,
Not the same
this is actually
company.
Japanese.
I know.
It's Japanese. These machines were designed specifically for the audio industry when they made millions of plugs and sockets and all that.
Is that true? This was specifically for the audio industry?
Absolutely.
That's
Plugs and
fascinating.
socket and everything else. You know, they would, because these machines can run 24 hours a day unmanned. Because you've got these magazines here, you see?
Yeah.
You load all this up, and once the bars run through here, the hood lifts, it ejects the bar into there, and then this rotates, and it drops another one in, loads it into the machine, and away it goes.
So it's an automatic, like a record changer.
Yeah.
Amazing.
The same with this
And that one feeds it.
That's actually internal, it's not electric. Because it's actually the same thing. You can see inside that magazine there's a number of bars.
Yeah.
And once it's finished, it will eject the end of the bar
Right.
and then load another bar into it.
And then that ends up in there.
Yeah.
And becomes parts.
Yeah. And then you can shut this everything down. As long as you leave the compressor on again, then you can leave it run for 24 hours.
Is this the same machine as that
That's
one?
the same as that, yeah. This is an earlier model.
And all this fluid is just to keep it cool, keep the parts cool.
coolant and it's a lubricant, it's cutting fluid as well.
Yeah.
They're the only machines that we actually use cutting oil. All of the other machines are soluble.
I
So,
see.
yeah. That's the driven pulley for a Model 20. So we buy it in billet form like that, and then the first part of the operation is we wrap it down and we put all the fixing holes in here. We need these holes in here for subsequent operations.
Right.
Okay, and then when those operations have been complete, we have blanking screws that we put in there
Right.
to blank it off, so there's no actual, you know, when the arm is tracking across, there's no hollow pieces.
Right.
And we do that with the platter as well. So we blank them all out with screws. So the first operation is to go from there to there, and then they move round to the next machine round the corner. We just have to pick up that machine over there to here. And that's what that machine now is doing. It's doing the top side of that, if you like. Okay. So
Right.
it comes like that. Now this machine here is doing that in readiness for the turning. Okay, so really what this is doing is getting rid of the excess material very quickly. You could do it on a turning machine, but it would take forever. A milling machine, you know, it's far quicker, and it's running in there now, you see.
Oh yeah.
All the things will be numbered. And here, number 24. And we'll keep a register of every piece of equipment. And then once in here, operation on there, where they're finally turned. So you do all of the diameter, you do the face, you do the bore, you do the register here. This is only just the relief. So, because you're turning all of the dimensions at the same time, it's perfectly concentric to the board. You're doing the bore and the diameter because the belt fits round here. So if you turn it there, you bore it at the same time. It's perfectly balanced and perfectly concentric.
So how long does it take to make one sub platter?
Probably an hour machining.
Yeah.
After an hour, then, you know, when they're finished here, this then has to go into the plating shop.
Right. So.
And then it has to be plated in there, and the plating process takes about another hour.
So from start to finish.
About 2 hours, 2.5 hours.
Yeah.
This, the control bracket, the Series 5 pickup arm.
Yeah.
Okay. Once we've die cast it and so on and clean the casting off, then we have to drill and tap it and put all these holes in here. So this here is actually a milling machine, but we've adapted it to be a 4-axis drilling machine. So we actually mount the brackets in that attitude like that.
Right.
Which will do that hole there, then it rotates, we drill and tap that there. So it does all those radial holes first. Then we take it off when we've done the whole tin, and then we load it on that face, and it's drilled and tapped there. The armrest sits on there. The little cover for the anti-skate mechanism sits in there.
Right.
And we drill and tap all of that. The little bush that we make with a Series 5 arm, it goes on the spindle.
For the alignment?
Yeah. We take these into our linishing department and we just linish the bottom of that face to clean it up. Then they go into the plating shop and they're jigged up. You could do a number of these. We'll probably do 40 or 50 of these on a plating jig at a time.
This is a new product too.
It is. It's in its early stages. All of this will have damping underneath. And if we look at the construction here, is there's an interface here between this and this, and it's all assembled in here and here, and the same layer. You see that there's a gap under there. There's isolation material in there that allows you to isolate one from the other, and the feet then are again adjustable. That's if you could ever lift them.
Yeah.
See, what the blasting in effect does, it's twofold. It gives you a key for the copper, because the surface is very slightly stippled, so it gives you a key for the copper to get hold of.
Right.
And it also cleans the surface. It's scrupulously clean now. Put your finger on there now and it will leave a fingerprint, and we'd have to take that out of the system. Because oil, even if it's finger grease, oil, you put it on a surface like that and you plate it.
Right, it's not going to work.
It will work. The plate won't stick. So you can see, I can touch that one because it hasn't been blasted. I wouldn't dare touch them because they have, and they're now ready for plating.
Right.
In the plating process, put on here. Commercially, people would put on maybe a minute.
Right.
We actually put 70 minutes on it, so you could, if you were to cross-hatch that with a knife and lift it, you can measure it. You can actually measure the thickness, and the thickness will be between 2.5 and 3 thousandths of an inch per surface. So it's like a very thin sheet. So then the moisture doesn't penetrate, it doesn't affect the copper of the material underneath. So then, having done all of that, I mean, we saw this on the machine down there.
Yeah.
Yeah, where they're all drilled and tapped and so on, under here.
And that doesn't affect the tap?
What you have to do is you have to have plus taps. So you have a standard
So
frame,
it's ready to,
plus
okay.
an allowance for these holes here. Okay, and then you pay huge amounts of money for plus